Here we want to consider a binomial probability distribution with P, and I believe P was equal to 0.3 and N was equal to 10. So the first part asks for the probability that X equals 3. So there's two ways to do this. For the probability that X equals 3, you could use the formula, and I'm just going to show you that. So on the top, we're going to have the factorial of n, which is 10. And then we are going to divide by n minus x factorial. So n is 10 and x is 3. So 10 minus 3 would be 7. So we're going to do the factorial of 7. And we want to times that by the factorial of x, which is 3, exclamation, or factorial. So let's put that there. And then I'm going to put a double parenthesis around the denominator just to be safe. And then we want to take that part and multiply it by P of X. So P is equal to 0.3, and we know X is 3. There's that little part. And then Q is just your probability of failure. So your success is 0.3, so your failure would be 0.7, because the probability is the total should be 1. So we're going to say 0.7 raised to n minus x. N is 10, x is 3, so that would be 7. Now we just want to take these 3 and multiply it. Okay, and we get 0.268828. Now that's if you use the formula, but you can use the Excel formula, binom.dist. Your number for x is always gonna be x and then n. So 3 and then 10, and then the probability of success is 0.3. And we just want it to be equal to 3. So we don't want it to be cumulative, so we put false. Okay, now for the probability that x is less than 3, well, that would be less than 3 would be x could equal 2, x could equal 1, and x could equal 0. So you would have to do this formula for each of these. So 2, 1, and 0, and then add those together once you plug this formula in. And we could do this, but it would be time consuming. So you would definitely want to use the binom.dist formula. We know x, we want it to go all the way up to 2, because less than 3 would include 2. So 2, then 10 for your sample, 0.3 for your probability of success, and we want it to be true because we want to include 2, 1, and 0, so we want it to be cumulative, and that's how you get the probability. Now, greater than or equal to 8. So remember, the probability is going to be the less than side of the curve. So we want it to be greater than or equal to 8. So if we find the probability of the other numbers from 0 to 7, let's do that. 7, 10, 0.3, and true. So this number includes everything we don't want, because we want 8 and above. So we can use the complement rule and say 1 minus the other side. And then you would get your probability. Hopefully this helps. If you have any questions, please let me know.